This is going to be Unit 1.5 in Algebra 2. Let me write that here. It's going to be our fifth set of notes in our first unit. And we're going to be talking a little bit about absolute value and how to solve when we see absolute value equations. Okay, if you're not familiar what absolute value is, just a little refresher. Absolute value is the units away, or I should say the number, let me rewrite that, number of units away from zero. Okay, so just a quick example, if we have a number line here and we have zero in the middle, let's say this is -1, -2, -3, -4, -5. And this is +1, 2, 3, 4, and 5. Okay, so if I say, what is the absolute value, and this is what these lines here are, what is the absolute value of -5? I'm asking you, how many units away is -5 from zero? So you would start here and you'd count 1, 2, 3, 4, 5, and we would say that -5 is 5 units away from zero. So that's how we find the absolute value. Now, in this case, they're asking if the absolute value of x is 7, what is the possible values of x? Okay, well, let's go back to this example of 5, right? Where I could say, what number can I put as x? What number can be x where the answer is 5? Well, we know that -5, which is what we had before, fit inside that equation, right? This -5, when we plugged it in there, it was 5 units away from zero. But what about +5, right? If I have a different color here, and if I go from +5 to zero, it'd be 1, 2, 3, 4, 5. Well, +5 is also 5 units away from zero. So if we're trying to find what the value of x could possibly be, it could be -5 or it could be +5, right? The absolute value of 5 is 5 because 5 is 5 units away from zero. And the absolute value of -5 is also 5, right? Because -5 is 5 units away from zero. So basically, whatever is inside the absolute value symbol is going to be the positive answer to that. So since this is 5, the positive answer to 5 would be 5. Since this is -5, the positive answer to that would be +5. So basically, anything inside those symbols is going to turn positive, and that would be the absolute value. You can also work backwards, where you could say that the -5 or +5 are both 5 units away from zero. So same thing here. If they say that what if x, the absolute value of x equals 7, what are the possible values of x? Well, we can say that -7 is 7 units away from zero, and so is +7. Okay. Now, let's look at number 2. It says, if the absolute value of x is -4, what are the possible values of x? Well, can anything be a negative distance away from something else? When we measure distance, we can't measure a negative distance. It's either 0 is my distance or a number larger than 0. Maybe it's I'm 1 foot away from my desk, or I'm 10 feet away from a chair, right? So we have to have a positive answer anytime we're looking at the distance away from something. So something cannot be a negative distance away from another object. So in this case, there is no value for x. It would not make sense for something to be a negative distance away. So you would say no value for x. If you want to add this to your notes, I would. You could say a number cannot be negative units from 0. Okay, let me clear some of this up. All right, so let's talk about the steps when we're trying to solve an equation, an absolute value equation. So if you were in my Algebra 1 class, you'd be pretty familiar with this, maybe just need a refresher. If not, that's okay, we're gonna go through pretty slow. So the first step is to isolate the absolute value expression. And one thing I want you to put here on your notes is this is important, and this is where most people tend to make mistakes, is you need to do this first. I mean, I know it says step one, right? But we tend to skip steps that we don't use all the time. And this is one of those things that we're not going to use all the time, but you need to make sure you check this first. Okay. Step two, create two cases. So it says set inside equal to both the positive and negative value of the number on the opposite side of the equal sign. And so one way I like to explain this is when you do this step, you are canceling out the absolute signs, the absolute value sign. So I'm going to write that here. Cancel out the absolute value sign symbol. I'm just going to write that. Cancel out the absolute value. So you can even put an X in here so you know that's for absolute value. Okay. And then solve both equations. Check for extraneous solution. So an extraneous solution is a false solution. I'm going to write that. A false solution that does not work when you plug it back in. And we'll see that in just a few moments. All right. So let's take a look at how that might look. Let's look at the first one. And so steps one says to isolate the absolute value expression. And we can see right here that the absolute value expression is actually already isolated. Where right here you'll see this example where the 3 is on the outside. Okay, this is not isolated. This is because the absolute value is by itself on the other side of the equal sign. Okay. So it's already isolated, so we're good there. Step two is we're going to create two cases. We're going to cancel out these absolute value signs by setting one positive, one of these answers positive, one of the fives a positive 5, and one of them negative. Okay, so this is what it's going to look like. You have x minus 9 equals 5. Okay, that's one possible solution. And then x minus 5 minus 9 equals negative 5. Because remember, the absolute value can either be, we can either have negative 5 right here, be 5 units away from 0, and we can have positive 5 be 5 units away from 0. So that's why we have to set up 2 to look at both the possible answers for x. And then we're going to solve for x like normal for both equations. So I'm going to add 9 to both sides. And now I have x equals 14. And then I'm going to add 9 to this side. And now I have x equals 4, positive 4. Okay, so I have two answers here, and I'm running out of space, so I'm going to show you the next step. We solve both equations, but then we need to check our solution. So we're going to plug them back in to make sure they make sense, because we're going to find out later that there are some answers that won't work for this equation. All right, so I think that the first x is going to be 14, so I'm going to plug it in back into the original equation. So I'm going to put 14 minus 9, the absolute value of 14 minus 9, we think it possibly equals 5. So 14 minus 5 is 5, and the absolute value of 5 is 5. So that checks out, that works. Let's try the next one. So we have the absolute value of 4 minus 9 equals 5. And so 4 minus 9 is negative 5. And we know that the absolute value of negative 5 is 5. So that checks out as well. So we know that both x equals 14 and x equals 4, those solutions work. and we're done with number 1. Let's look at number 6, where we have something on the outside of the equation. And this is where we are going to have to use our step 1. Step 1 says to isolate the absolute value expression. So now, before we can solve, we need to get this 3 to the other side of the equation. So we're going to divide both sides by 3, and that cancels this out. So now I have the absolute value of m plus 8 equals, this is going to be 13. All right, so let's go ahead and cancel out, right? Our step 2, cancel out our absolute value signs, make one equal to positive 13 and one equal to negative 13. Okay, so I'm going to subtract 8 from both sides. So now I have m equals 8, 5. And then here I'm going to be adding. So now I have m equals negative 22. So let me go ahead and clean this up and so that way we have room to check our answers. Okay, and we're going to plug these numbers back into the original equation. So we're going to keep everything the same. So I have 3 times the absolute value of 5 plus 8 equals 39. So 5 plus 8 is 13. And then the absolute value, let me not skip a step. So we have the 13. The absolute value of 13 is 13. Now I can bring down my 3. 3 times 13 is in fact 39, so that checks out. Let's do the next one. I have 3 times the absolute value of negative 22 plus 8 equals 39. Well, yeah, negative 22 plus 8 is negative 13. And we know the absolute value of negative 13 is 13. And now we have the same equation as the one to the left, where 13 times 3 is positive 39. So that checks out as well. All right, let's look at one that's a little bit more interesting. Let's look at number 14. Okay. Well, first step first, like I said, we need to isolate. We need to isolate our absolute value symbol. So we're going to divide both sides by 2 to get this 2 canceled out. I'm going to rewrite our problem. So we have the absolute value of h plus 8 equals now 7 times h. Okay, so we're going to make one solution negative and one solution positive to cancel out our absolute value symbols. So I have h plus 8 equals negative 7h. And then I have h plus 8 equals 7 times h. All right, now we're going to put our h's to the same side. So I'm going to subtract h. That's going to give me negative 8h equals 8. Now I have h is negative 1. And then on this one, we're going to bring our h to the other side. This is going to give me 6h equals 8, and then divide by 6 on both sides. We have 8 over 6. We're going to reduce that to 4 over 3 equals h. Let me go ahead and make some room, and then we'll go ahead and plug our numbers back in. Okay, so we think that the first one is negative 1, so let's go ahead and plug it in. So I have 2 times the absolute value of negative 1 plus 8 equals 14. And we have another h, so we need to plug in negative 1 on this side as well. So 14 times negative 1 is negative 14. Then we have negative 1 plus 7 is the absolute value, I'm sorry, plus 8 is the absolute value of 7. And the absolute value of 7 is going to be 7. And 7 times 2 is 14. Now, the problem I'm seeing here is that this side is a negative 14. So negative 14 cannot equal 14. So this does not make sense. When I plug this negative 1 back in, It did not work. So I'm going to cross this answer out. I know that it cannot be -1. Let's try the next problem or the next solution that we came to. So we have 2 times the absolute value of 4/3 plus 8 equals 14 times 4/3. Let's go ahead and take care of the right side since that's a little bit simpler. And we have, okay, so 14 times 4 is 56. And that's going to be 56/3. And it doesn't look like we can simplify that anymore. Let's try the other side. And in order to add, we need to change these to be the same denominator. One quick trick I like to do is multiply this number by this denominator, then add it to the 4. So 8 times 3 is 24, and 24 plus 4 is 28. So this is going to be 28/3 times 2. Well, 2 times 28 is in fact 56. So now I have 56/3 equals 56/3. And that makes sense. That checks out. So in this case, the only solution set we have is 4/3. Or question I did actually want to throw in there is number 7. And this kind of is a trick question, and I'll show you why. So we know that our step 1 tells us at the top of this is to isolate the absolute value expression. So if we look at number 7, we see that our absolute value expression um, has a 16 on the outside of it, right? The 16 here. So we need to go ahead and get the 16 to the other side. And so we're going to divide by 16 on both sides. So now we have the absolute value of r minus 5 equals -2. All right, next step would tell us to solve, but if you remember back when we were taking our notes on this, back at the top of your page, that anything inside the absolute value symbol cannot equal a negative number, okay? Anything, any absolute value, the absolute value of something has to be a positive number because a distance cannot be a negative distance. It's always a positive distance away. Same thing goes here. No matter what number we put in as r, we cannot get a negative answer. So in this case, it would be a no solution problem because nothing can be negative to distance, a negative to distance away from 0. No other number can be.